Welcome to the second day of State of Open, the security track, which is the best track. I am going to be talking today about fixing open source cybersecurity by 2030. Originally, this talk was going to be regulation by telemetry, basically stating what most of you have heard from me, which is the request from SBOMs is too cloud-centric and very difficult for us to execute in real time. I don't want to talk about that today. I think there's more interesting things we can cover. Do check out some of the links that I'm going to be talking about. Are going to be covering OSSF, some of their working groups, Alpha Omega. And if you look at this links tree, you'll be able to access all of those immediately. So where you know me from, I'm a DevSecOps engineer. I come from the security clearance space from the US. And I primarily was working on real-time anomaly detection, which is the kind of security that I do. I'm not so interested in static security and in static binaries. I'm very interested in real-time events when we're running with large systems. I am a startup tech lead. I've worked with several of you on paid and unpaid basis in the Innovation UK grant space. If you've got an interesting problem to solve, sometimes I do help with that data science. And I am trained in both computer science and in public law, which is incredibly important to understand in a space where we work on licenses. If you know me from open source, I have been a maintainer and an advocate for projects in both chaos engineering, site reliability engineering, and cybersecurity, meaning when I am at work or building things for developers, it's typically aimed at people that have to deal with severe incidents, again, in real time. And philosophically, I only work on what I care about, which is really beautiful in open source, because I'll do that for free. But what I'm working on right now are two problems. I'm very interested in using runtime observability, like eBPF, which you will learn more about later today, in supercomputing to see if we can reduce the carbon cost of those and also raise interesting runtime security concerns. Outside of that, I am an advisor for digital sovereignty for our worlds, which is a native owned and run VR or XR experience, which is fascinating. And in that space, I'm very, very interested. Coming from a tribal reservation space myself, I have a dual sort of responsibility and a dual citizenship, both as a US citizen and as a citizen of my tribal nation. We are trying to surface and tell our stories in an incredibly responsible way. The data sets that we receive from these sometimes do have really, really interesting security concerns or sovereignty concerns. And increasingly, I'm interested in understanding how the underrepresented populations of open source are changing it. And on Linktree, go watch this, because everybody thinks that the original code talkers were Navajo. There was one that happened in the early 1900s, and no one knew that the Choctaw code talkers were the first ones. Why? Because it was wrapped up in security clearance, and we didn't know about it until France came and provided a Medal of Honor to the surviving members of those code talkers, to the Choctaw Nation specifically, not to the US, because it's a different sovereign nation, and they were able, as French citizens of a French nation state, was able to come in and talk to a sovereign state. So when I say sovereign state, I really mean it. These are political entities, political bodies. Now here's what we're going to learn today. I'm going to give you a run through of how to choose the best open source components with math. It's a nice way to sort of wrap together some of the things we talked about yesterday. Ecosystem hardening, how we need to deal with sort of the cultural approach to this at the maintainer level, and new threats. I think there is a very real threat around the new types of people that are coming into open source, the kind of culture that existed before open source was more corporate than it is now. And I'm going to explain how we need to approach that. Before I do that, let's cover open source licenses basically. Typically, if you're building a product, you're going to have business intelligence, code artifact, and a code-based development, all of which have levels of IP. If you're using open source, you can use any open source that you want, really, internally. I don't really care. externally, I really do have to make sure that I am using a standard of license that is appropriate for my usage as soon as that code can be seen or utilized by an integration or a party, it matters. Now, IP rights and the open web. Intellectual property rights are just the use of creation and the right to your own use as a creator. This is very important for you to understand as maintainers of IP. The public web is the generally open web, but open source and fair use are really interesting in this case. Fair use is just an affirmative defense of copyright, and if you want to know more about all of that, Amanda Brock is the one to talk to. Open source is the license statement of the rights. These are the most common ones. Everyone in this room typically knows what these are. But I always like to bring up this example because I think it's genuinely illustrative, and if you are dealing with anyone in your organization who doesn't understand open source architecture or licenses, tell them to check out Shiv Integer. So Thingiverse allows us to go and get the binaries for anything that you want to build for a 3D printer. And what Julian did was go and scrape everything that was compliant, so everything that had the same license, and create these beautiful random art projects. It's beautiful, it's interesting. That's a way to describe open source architecture to someone who doesn't understand it. But really, it was to demonstrate the ethics and requirements of legality in open source, which is very cool. The last statement that I'm going to have around this, I think, is really important to understand. So copyright applies to all creative work. Trademark identifies a brand. Patent protects innovations. And open source licenses are enabled sharing. Why don't we patent open source? It's very historically simple because originally these were binaries, zeros and ones, and you cannot patent numbers. That was the beginning of open source licenses, and we have developed a very interesting and, in my opinion, new legal and ethical domain because of that. So, how do we choose the best open source packages securely? 96% of vulnerable downloads are avoidable. How do we avoid those? You can't just put in Dependabot, you can't just make assumptions, because this is increasing year over year. The supply chain attacks, I hate that number. Now, let me tell you a little bit about yourself. If you are a developer, you're going to be pretty confident that you're not using vulnerable versions. If you might be, here's one of the important takeaways from this. Your managers are significantly more confident than your developers are at your ability to handle 0 days. And that's because they are aware of our best practices and whether or not they're in place. So managers do need to have a stronger empathy for these PagerDuty incidents. They do need to understand that one-day remediation is ideal, but you might not be hitting that here. So why are we making imperfect decisions? Because open source is a little bit hard. So 64% are just suboptimal decisions. They're not necessarily very high risk, but they will lead to more developer time in refactoring later, and that's important to me. A really cool way to check out whether or not an open source package is being well maintained and securely maintained is Sonatype's mean timed update. I really, really like this from the research team. What they did here is calculate when an open source package updates with a version, how well did they do, and how often did they update what they were bringing into their dependencies? So it strongly correlates to mean time to remediation, and I think this tells a really, really simple story. Why does mean time to update of your open source package have the strongest predictive relationship to mean time to remediation when none of the other predictive measures that we have out there, source rank, none of them were strongly predictive? MTTU super helps with this. It's because when you are intaking and ingesting open source, you are accepting the risks, but you're also accepting the quality of that maintainers, of that pipeline. And unless you can calculate that quality, you really don't know how to go. So here's some of the options that you can use, and you can use these sort of together as you're trying to decide what is a good open source package. But these early approaches, libraries IO and OpenSSF criticality, they're good and they can be used in combination, but individually they're not highly predictive of whether or not a open source package is going to have a vulnerability in 3 to 6 months. Last note on this, MTTU is accelerating. This is incredibly important because the entire open source field is both expanding and accelerating, meaning that it's very likely that you are going to have to update your packages inside or at the same rate as your sprints moving forward. So if you're trying to make these decisions manually, you don't have any dev time left. So Sonatype did this incredible research this year that I thought was really, really interesting. So we've got survey data, download data, app scan data, and OSS security practices, specifically the OpenSSF scorecard that we learned about yesterday. Now, Log4j. I've said, I don't want to talk about this anymore, but we have to, because Log4j and Log4Shell really showed us that when you have a severe vulnerability with this kind of open source surface area, we want to have rapid remediation, but we have not gotten that. In part, there's 2 different reasons. Yes, because sometimes these are locked inside of your jars and Uber jars and they're just difficult to scan for. But there is a much bigger concern here that there are a good 35% of Log4j, Log4Shell sitting out there, possibly because there's just a not strong enough awareness of this critical CVE, because we are doing a lot of this zero-day disclosure essentially by Twitter and other social vectors instead of standardizing and centralizing that. This is increasingly changing with some of the implementations that OSSF and the surrounding groups have put in place, but these numbers are drastic and terrify me, because those are open backdoors. Now, my last statement, and if you haven't read the Sonatype report yet, there's a reason why it's been mentioned several times. It's very good. So on average, an open source library is going to have about 5.7 dependencies. Now, if you've got about 150 dependencies inside of your project, we're talking specifically Java here, you could have up to 1,500 updates to consider in a year, and that's just not possible to do if you're doing it manually. So if you want better metrics to predict vulnerabilities, the aggregate measures are here. The aggregate measures open source criticality, security scorecard, library source rate, mean time to update, not meet, and popularity. In combining those, we've got a really good idea of what works best. I just want to step back for a second and explain why some of those factors are highly predictive in the inverse. So it's very easy to think about, common sense. If you have a package that is vulnerable, here's the things that it's probably going to be doing. It doesn't have a code reveal. It doesn't have a binary that I can scan. It pins its dependencies, which is just irritating and bad practice generally, but it's a severe security concern. And you don't have branch protection. So coming out of Sonatype's last year of research, I really found this interesting. How do we predict and inform a consuming open source user? And sitting right there on Maven Central is the Sonatype safety rating. So if you can understand the underpinnings of that, you begin to understand how important it is and how building out these ecosystems of the OSSF scorecard, making sure that those are integrated, making sure that everything's updated in an ecosystem can improve it. Now, this isn't perfect, but it's pretty good. 86% accuracy. So go check this out and read that report if you haven't already, because I left out a lot of cool elements to that. But you want to favor open source packages with smaller dependency trees. Look for ones that have a quick update, a good MTTU, and minimize the total number of dependencies and maintaining that maintaining low update times. Because it's the transitive dependencies that are killing us, right? It's not necessarily that open source package, but it's the fact that that OS package pulls in an OS package that pulls in an OS package that is vulnerable. And if you do this well, you can save yourself money, but for me, as a developer, it's mostly time. This is really irritating toil. Security refactors are irritating, and they have to be dealt with right away, right? And incident events, there's no way to avoid them. So, if I want to avoid having to do a security incident refactor in my own corporation, maybe I can just focus on fixing the ecosystem, I thought 2 years ago. And so I joined Sonatype and I said, all right, let's go out and reach that maintainer class. Let's get some education out there, and let's harden some of these ecosystems that I deeply care about, particularly Kubernetes. So we ran 2 different types of events. We ran a bug bash twice, which is interesting. So we all understand this open source contributor model of having an OS project, a maintainer, and a contributor. Now, what we did was go and do a static scan of the binaries for participating CNCF projects. We gave them a list of known vulnerabilities, and then we worked to bring their contributor base to learn how to solve and harden that package. I think that's really important because culturally we're only incentivized, I mean, not even culturally, we as human beings are only incentivized to work on things that matter to us. So really embedding that education with the maintainers and their strong contributors really worked well. Then we shifted strategy because as I was reaching out and working with these maintainers through the bug bashes, those were successful, good implementations of reducing vulnerabilities for major packages. But there's a lack of education and training and understanding about security in the maintainer class more generally, to the extreme that sometimes I will have to reach out and communicate a 0-day, but I don't have any way to do that for some of these packages. They don't even have a security MD file. So training that really basically became very important to me in Kubernetes. So there's the CLO monitor, which goes through and checks every incubating CNCF project, and it sort of evaluates what their current best practices are. And it gives you a nice little neat score. And I said, wow, there's one project in all of CNCF with a 100% security score. Can we improve that? It's Pixie, by the way. I love Pixie. So this was really neat because it was educational intervention, but we did it in a really creative way. So maintainers got awards, recognition, financial support, faster time to compliance, security enablement. We are pushing an entire cohort of maintainers and projects up through the incubator in tandem, which I think is very important. Number 2, contributors got rewards, recognition, and we worked with Google to provide up to $50,000 to the CNCF Diversity Scholarship for every project that got up to 100%. And that was just a really cool cherry on top. But wait, there's more. So we've talked more generally in security, really from that sort of like corporate nation-state protection space. And I think it's very important to understand that the corporate culture of open source is different from open source in the wild. And there are actors and agents and maintainers in open source that will never integrate into a corporate culture, unless they're paid. I found this protestware from Marek really interesting. They put out a bid about a year before they went to shut down their repository, saying, pay me or I'm taking down these 2 packages. And then they DOS'd it. So they put a security, they DOS'd all of their end user. We're talking like a massive surface area when that occurred. Really interestingly here, the sort of solution to this was GitHub Microsoft took this maintainer's repository away from them, and they now own and run that code, not a fork, that repo. The license on that repository did not allow for that to happen. That, I think, is a major fumble. It's clearly illegal. It's just not usually actioned on legally, unless you're Rob Landry. This, in open source in the wild, scared a lot of people because this is a platform acting as a sovereign, acting as if they are not beholden to the rights and obligations of open source licenses. And you can't tell me that GitHub doesn't know what open source licenses are. Sovereignty politic. I think that this is where we need to have a little bit more education. I particularly have a background in this because I've worked and lived tribal politics. But a lot of those are very interesting to reference here and give us a better understanding of how we're going to deal with autonomous agents moving forward in open source. So sovereignty. It's a supreme power, especially over a body politic, freedom from external control or a controlling influence. It also implies a set of practices closely related to the production of knowledge about populations, territories, and resources. This is fascinating to me when we are dealing with this idea of open source and the idea of the commons. We always talk about the commons, but we don't talk about the feudal structure sitting on top of them and how we are recreating those digitally, for better and for worse. The development of sovereign political entities relies on that creation of bureaucratic and centralized administrations and tools whose vocation is to quantify and, by doing so, make a population legible and therefore governable. So who are we governing? A people considered as a collective unit. In open source, body politic is typically best partitioned not by sector, but by language. It is also very important to understand that packages themselves aren't necessarily tied directly to the corporations which may be sponsoring them. That maintainer or maintainers connected to that occasionally have full autonomy and may not have the same interest as a corporation. So sovereignty security requires really thinking about this differently. How are we going to begin behaving in a way where maintainers of projects with different backgrounds, different beliefs, and different priorities from your own can be respected? So, we've got a couple of initiatives in security which are interesting. There's the OpenSSF, which I'm not going to speak a ton to because we've got people in the room who can speak much better to it. We've also got the Alpha Omega project, which is very interesting. So OpenSSF is a sub-foundation of the Linux Foundation intended to work on security. Within that, the Alpha Omega really, really fascinates me because Alpha and Omega, the intention of coming in and doing some quick interventions right now to security, but the long tail of Omega is securely integrating real technical solutions at scale. Really pay attention to the Omega of this. I find it really interesting. I'm not personally going to speak to it in this talk, but I hope that we cover some of that that's coming up and how you as an individual might be able to get involved. So some major blockers to secure open source from my perspective. One, we have to develop modern security education that globally scales. The major issue right now is just I literally can't hire anyone who has experience in supply chain security because it's too new. And we don't teach cybersecurity, modern cybersecurity, in any university well at this time. We don't really have that in place. Now, this is why I'd like to highlight the best SIG in OSSF, according to ourselves. That is the education SIG. We typically meet bi-monthly on Wednesdays. You can join that meeting anytime. We have just worked with the US government to attempt to provide an overview of how we can start educating for free on the open web to provide those real-time trainings to those who are either jumping into industry or want to improve their security in situ. Particularly, my focus in this space is on the third pillar, which is rewards and incentives for developers. Why? Because I care about maintainers, and that is a space where I can ensure that security is something that you get paid to work on because it is necessary that we start to put that in place. Number two, I think this is real and we need to talk about it. I'm concerned right now that OSSF is too cloud-centric. CNCF is not all of Linux Foundation, and unfortunately, as someone who is back to building supercomputers, cloud also runs on hardware. We need to be able to communicate those concerns about a full hardware, software security profile, and I really want that discussion to be had moving forward. Number three, runtime security. Runtime security is what I've been complaining about for years. It's a real increasing attack surface and likely requires a cross-foundation approach. My last statement on this is that within OSSF, there's the right education and understanding and incentives for security, but not for runtime. If you want those, what you're going to need to do is jump to the AILF Foundation, because the developers working on sort of eBPF, observability of runtime, are sitting over there. We've got security conditions for runtime that we could execute from, but we need to do that in combination. I'd like to continue that idea. My wonderful second laptop has died, so my last note on this is that I really want us to think differently, because the last slide on here was not OSSF or any of that. It's the fact that we have an increasing number of globalized open source contributors coming into play right now. And if we do not build systems into place that respect cultural differences and sovereignty, we're just going to have a security wildfire that we cannot possibly put out. Every maintainer has the ability to be an autonomous agent within the basis of the license that they have put out. They've got their own rights and obligations, and we need to have structures that really work well for that worldview and that type of politic. I don't think we do yet. I will stop there because one of the last things that I think is very important is understanding languages, language ecosystems, and the idea of sunk cost. So it is true that the COP10 initiative, the attempt to keep green sort of carbon production below 2%, 49% of the total usage of the existing infrastructure for fossil fuels was implemented after COP10. Does that seem irrational or highly rational? It's highly rational because that infrastructure was very expensive and they want to make maximum gains out of that before they retire that. Why is that relevant to open source? Because there's a couple of languages that are highly valuable, used in corporate infrastructure, but aren't the best solution possible. Not for security and not for green production either. On that note, I would love to invite our next speaker, Rebecca Rumble, who is going to explain to you security in the language of Rust. Thank you so much.